Hello everyone, myself Saitya and I'm currently pursuing my BTech third year degree from VIT University. I'm here to explain about the task which was assigned to me was EVM bytecode analyzer. So the main problem of the task was on the Ethereum blockchain, smart contracts addresses are stored as bytecodes, as we already know about that, which can be read only by the machines because it is a mission level code and it is very difficult for the humans to read. So to overcome this problem, I built an EVM bytecode analyzer so that it takes a smart contract address and fetches its bytecode from the blockchain and analyzes it so that it converts into the human readable code. Now I will demonstrate how the analyzer works by let me show you the files that I have created, and here is the main folder which is EVM bytecode analyzer, and these are the files that we need to work on this project. So mainly in the core folder we have the main logic of the analyzers. There are mainly four analyzers that we are using. The first one is disassembler, which means it converts the bytecode into the opcodes. So here is the code as you can see, and there will be the human readable instructions as well here. And the next one is selector extractor, which means that it extracts function selectors from bytecodes and resolves them into human readable functions. So yeah, these are all the human readable functions. Next one, see, as we can see here, these are all the human readable functions. Next one is CFG, which means that control flow graph. So here why we use this one is it builds a CFG by dividing instructions into basic blocks. So it will divide the blocks into basic blocks. Here the block count, which means it divides the instructions into basic blocks, so it will give us the numbers. So this is the main things we have to see here. Next, the fourth one is the security. So security is used to detect the vulnerabilities, and it serves the bytecode for security related opcode patterns. Bytecode fetcher, it fetches the bytecode from the blockchain using RPC method. So that's why we are using this code and all. Let's see how we analyze works using the CLI interface. So for that, we need to open the command prompt first. From here, we will open the CMD. We need to start it with npm install. After it getting installed, next we have to run the build function. The build is also successful. Now we need to start the process. So I have the command line that I have saved to get the output for this each contact address with the four analyzers, the system selectors and CFG, and the last one is security. Based on this contact address, the four analyzers analyze the address and it converts into the human readable code. Wait, let me show you how it will do. Yes. The first one is diacism as we provided. So diacism means it converts raw bytecode into readable EVM instructions so we can understand the contract logic. So here we can see these 0x000002. These all are the offset values and these are the hexadecimal values. And here these are the human readable instructions: push one, mstore, call data size, LP, jump by, these all. So push one means it is a human readable representation of the opcode. The instruction pushes 1 byte of data onto the EVM stack. Next, mstore means store value. So like this, for each of the human readable instruction there is a significant function that will carry. Next, the second one that we have given is analyzer, selectors analyzers. So for these selectors, it is showing that detected as 32, which means that only 32 unique function selectors are detected. So here 0x06, it is the 4-byte function selector extracted from the bytecode. Next, the likely signature, it indicates name of, which means that human readable function signature. So next, candidates found is 3, which means that it indicates how many possible function signatures were found. Candidate preview, this lists the candidate function signatures. These three are the candidate function signatures. Next, it is showing the status is resolved, which means that analyzer successfully mapped the selector to a known function. So if we got results over here, so it means that it maps the selector to a non-function. So like this, for each of the bytecodes we will having the corresponding attributes. Next, the third one is CFG. So CFG means it is a basic block of sequence of instructions that has only one entry point and one exit point. So here we can see there are two jumps. Whereas static jump, which means that the destination address is already determined during analysis. In dynamic jumps, the destination is not determined, but it will get determined during runtime and cannot be resolved. So you can see here the static jumps is 183 and dynamic jumps are 55. So static resolution percent is nothing but the percentage of both the static and dynamic jumps. Next, coming to the block count, whereas the analyzer divides the bytecode into, here it mentioned 371 bytecodes, and the CFG will detect it. Next, edge count. Edge count means represent connections between basic blocks. So there are 339. Next, let's see the security thing. Security analyzer is mainly used to scan the disassembled bytecode and the CFG to detect patterns that are commonly associated with smart architectural behaviors. So self-destruct, as we can see, which means that it is used to delete the contact permanently and transforms the remaining ETH to H addresses. So next, the second one is here. You can see that the detector is false, which means that there is no self-destructive presence. Next, proxy contract, which means that nobody can steal the information, which also detected as false. Next, these are all the about the analysis that how we will get the outputs. As we got output for the first one, so let me try with the other two commands that I have with me. So this is the another contact address that I have. So for this one as well, we will get the output for each of the analyzer, what the each operation will perform. So you can see for the decision, so it converts these bytecodes into the human readable instructions here. Next, coming to the security, it is showing the how many evidence offsets are recorded and all for each of these. Next, CFG, it is showing the counts and jumps values, and for the selectors it is showing how many detected, how many candidates found, and all. And these are the human readable instructions, and the status is now resolved. So and we will go to the another one as well to try it. Let me try this with the third one as well. For the third one also, we got the outputs for the selector sunriser, and then for the security, and for the CFG, and for the dash. I have implemented the whole project, and that is available into the GitHub as well, whereas I have created a repository which is EVM bytecode analyzer. So here you can see all my files and all. From here you will get the all files. So then this is the readme file. So this is the whole repository. Next, I have also deployed this in on render, where you can see the URL from here. So here is the render URL. Yeah, you can see. Yeah, here you can see that I have deployed this project. Here I have deployed my project. So not only the deployment process, I have used the Postman API also to it also REST API endpoint, and it allows users to send a contact address and receive a structured JSON analysis report. So from starting, I will show you. From the GitHub, the field URL is there. So we need to select post here. After selecting post, the body, and then run. So to give the input here, I have already pasted some of the commands here right now. As you can see, I have 4 inputs with me. So first I will start with the first one. We have to click on the sign button. So from this, by giving this input, we will get the corresponding JSON format output. For these 4 analyzers, we are initializing the variables as true, and we will get the output in JSON format. Yeah, we got the output here. For the selector of this bytecode, we are getting the offset value as 55 and the jump target value as 4W. For each of the bytecode, we got separate offset values and the jump target values based on the bytecodes. Next one is that Here, from here, the security, yeah, CFG has started, and it has the block count of 371 and edge count as 339. Static jumps are 183, dynamic jumps are 55, and the percentage was 76 to 89. And here is the security. It is showing the detected as false. And unchecked terminal calls we got detected as true. And other findings, what we have found, which pattern, and how is the severity in the bytecode. So this all will comes in with the findings. So for this address we got this output, and if we change the another, let me try with the second one as well. So now we have to click on the send button. So after that, yeah, here we got the output same as the. Now coming to the third one, let me try with the third address as well. This is the fourth address that we have tried. So this is the project that I have made, and thank you very much for giving me this opportunity to prove my skill and ability. So as coming to the conclusion, I will conclude this by this tool helps to developers and auditors understand smart contract addresses directly from bytecode, even when the original source code is not available. So we can easily understand, and we can use anywhere if we want. And thank you very much.